So to implement source NAT, let's go ahead and use this topology, and let's create a network object for the network 10.3.0. And there's going to be a checkbox when we create the network object representing that network. There's a checkbox next to NAT that we can check and tell it that we wanted to do network address translation on behalf of any IP addresses coming from that network as those packets are forwarded out the interface leading to the external network. In this case, we have our simulated internet right here off of E0 on firewall 2. And the second question is for source NAT. If we're translating the source IP addresses of these clients, what IP address do we want to translate them to before we forward the packets out? And we have several options. We could use the interface associated with E0, which is 67.83.0.112, or if we had assigned to us the IP address of .200, 67.83.0.200 from our service provider, we could use that IP address. The key is, whatever address we use, we have to make sure that the internet, if we send a packet from that source address, we need to make sure the internet forwards reply packets back over to our firewall so it can do the untranslation and forward the response back to the initial client. And also for our test, we could use ping or trace RT from this Windows client over here on the branch network. And let's go ahead and, for a target, let's go ahead and send pings or do a trace RT over to 67.83.0.111. And then we can look at the logs and verify that network address translation has been taking place on firewall 2 based on the NAT rules that we've set up. So let's begin on our management PC. We'll launch Smart Console and we'll connect over to our management server at .110. So we'll click Login to do that. So with Smart Console up and running on our management PC, let's go over to a machine that's currently connected to the branch network. And that would be in this topology DC NUG at the moment. So DC NUG in the lab environment is sitting on this network. It's got the IP address of .100. And before we implement source address translation or hide NAT here on firewall 2, let's go ahead and do a trace RT over to .111. And that'll do a couple of great things for us. Number one, it's going to verify the path that we're currently taking for this PC to reach that interface on firewall 1. And then secondly, it can also go ahead and generate the traffic going through firewall 2 before we implement the network address translation. And that way we can take a look at the before and after and compare the two. So here on the DC NUG computer, let's go ahead and do a trace RT space -D. That'll save us some time because it won't be trying to do the name resolution for each of the hops in the path. And then we'll put in the target of 67.83.0.111 and press enter. So to confirm our path, the first hop is 10.3.0.12. That's here. And then the second leg of our journey is from here to .111. Great, that looks fantastic. Let's go back to our management PC and take a look at the logs. So back on the management PC, if we click on the logs and monitors tab over here on the left and give that a second to load, here we have our echo requests, first seen on firewall 2 and then seen on firewall 1. So if we take a look at the log reported by firewall 2, if we double click on that to bring it up, it's got the source IP address, it's got the destination IP address, it identified it as an ICMP echo request. But notice on here, it does not say anything about network address translation. And that's because we have not implemented any network address translation rules regarding this traffic flow yet. So let's go ahead and change that. We'll close the log details window. And for grins, let's go back to our security policies. So here on the left, we'll click on security policies. And under access control, we have a policy regarding NAT. Now currently, everything that's configured regarding network address translation is due to the defaults. So what we can do is we can create a new object that represents the 10.3.0 network and put a check in the checkbox that says we want to do network address translation. So one of the options for creating and manipulating a network object is to go up here in the top left to Objects, click on Objects, and then from the drop down, we could say New Network, New Host. We could also bring up the Object Explorer to see all the existing objects that we have. So let's do that for a moment just to make sure we don't already have an object related to the 10.3.0 network. And to narrow it down a little bit, I'm going to go ahead right here and just type in 10.3.0.0, press enter. And the only object that includes that IP address is, if we expand this, is an address range. And that's an address range that includes everything. So we don't already have a network object for 10.3.0, so we can just create one. We can simply click on the New button right here. And then from the drop down, we'll select Network. We're going to create a new network object. Let's call this Branch Office. And for the address, it's going to be 10.3.0.0 with a 24-bit mask. So we'll put that in, and then we'll go ahead and click on NAT right here. So regarding the branch office object, which is the 10.3.0 network, we'll click on NAT. And if we want to do source NAT for packets that are sourced from this network address space and going out through the firewall to an external network, we simply click on this checkbox right here. Add automatic address translation rules. And then we have two options in the translation method. Hide, which is dynamic NAT or PAT for source address translation. And with hide NAT, we can have thousands of IP addresses hiding behind a single translated address. And the other option, static, is if we wanted a one-to-one mapping. And that's where we'd have a single global routable address mapped to a single inside address or single DMZ address. So in our case, we want to use hide NAT. And then the top radio button says, do you want to use the IP address that's already in use by the gateway itself? So in our topology, that would be 67.83.0.112 on firewall 2 on its outside interface. Or, says the second radio button, or do you want to use a specific IP address? And for this demonstration, let's go ahead and use 67.83.0.200 based on our plan. And then finally, which firewalls should implement this policy? And because that source network of 10.3.0 is unique, at least in our topology, for our branch office, we're just going to have firewall 2 implement that policy. So regarding the option install on gateway, we'll specify firewall 2 and then click OK. So let's go ahead and publish that. And we'll also close the Object Explorer. Back here under our access control and NAT policy, it added for us these two rules right here, with the second one being the most interesting, which says regarding the branch office object, the 10.3.0 network, if that's the source IP address involved, as packets are being sent out to the external network, in this case our simulated internet, we want to go ahead and translate the source IP address, and that little H right there is representing hide NAT. So any source IP addresses on the 10.3.0 network as they're going out are going to be translated to the IP address we specified of 67.83.0.200. And that policy has been implemented on firewall 2, or it will be once we click on the install policy button. So we'll go ahead and click on install policy. We'll push it out to all of our firewalls, even though firewall 1 isn't getting any new information. This is really just changes for firewall 2. And we'll give that a few moments to complete. And now that it's done, that's great. Let's go back to our logs and monitor. And let's generate some new traffic so we can verify the translations. So let's go back to our computer on the branch network, which in this example is going to be DC-nug. And DC-nug is asking me to authenticate again, so I'll also apply the lab password. And then back at the command prompt, we'll just hit the up arrow to do that trace RT command again and press enter. That continues to work. The path is still the same. And now let's go back to our management PC and take a look at the logs. So back at our client-nug computer, the administrative PC, we'll go ahead and click on the refresh icon right here to see the latest and greatest information. And, and here they are. So I've got the first one right here regarding ICMP, and the second one regarding ICMP is right here, and that's being reported off of firewall 1. And then I've got some NetBIOS garbage going on with these two right here. So when you do this hands-on lab, your mileage may vary based on what else came in at the exact moment you were doing your trace. And our focus regarding network address translation is this one right here, because firewall 2 should have done translation on that initial packet. So let me expand the columns a little bit. And let's double-click on this entry from firewall 2. So we'll double-click on that to bring up the log details, and check this out. It's got the source IP address of our PC at the branch office. It's got the destination address. And then there's a section called Network Address Translation. And in this log, it indicates that it translated the source address, which was 10.3.0.100 initially, and it translated that source address over to 67.83.0.200 based on that network address translation rule that we associated with the 10.3.0 network object. So that confirms that the initial network address translation is happening, and if we close this log detail window, and we go to the firewall 1 information regarding ICMP right here, firewall 1 sees this as coming in from that IP address that firewall 2 did the translation on, going to the address of .111. And now that we've gone through this nugget together with this demonstration, I would encourage you to use the hands-on lab associated with this nugget when you're logged on to cbtnuggets.com. And that way you can practice right alongside with me in working with dynamic NAT. So have some fun with the lab, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.